We were talking about torque, we were talking about Newton's second law of motion for rotation, and we were talking about how to apply this when an object is in rotation. Now, what would happen if an object is executing translation plus rotation? So, whenever an object executes translation plus rotation, in a very specific case, it is called rolling. Okay, it is not always called rolling. I will keep on calling it translation plus rotation. In very, very specific cases, under some other conditions, it is called rolling. I will tell you what those conditions are. So, what is the meaning of rotation plus translation? It means that a rigid body is moving in such a way, okay, and the statement is very, very important. A rigid body is moving in such a way that its center of mass is translating and the body is rotating about its center of mass. Okay. The center of mass is translating and the body is rotating about its center of mass. So this is a very simple theorem that we are going to use. So the theorem is that motion of any rigid body is equal to motion of Cn plus rotation about Cn. So what does this mean? What will you see when you look at an object which is rotating and translating? Well, you are going to see a rigid body whose center of mass is moving. The motion may be any kind of motion that you have learned about. It may be straight line motion, it may be parabolic, it may be circular, okay? It may be any number of types of motions. And you will also see that the object is rotating about its center of mass. It turns out that these two quantities are independent of each other. And it makes sense also because up till now we were not considering rigid bodies, although we were talking about blocks and wedges and cars and people. But we were only talking about the translation of these objects. And we were not bothered even about the rotation. So in all the problems that we have done, where there were cars, where there were wedges, where there were sticks, ladders, something like that, which we considered to be a point particle, and we only considered the motion, the translation of the point particle, we were actually only talking about the first piece of it. And now we are going to incorporate the rotation into it as well. So I think we had this discussion in the last class where there is this tendency, and this tendency is there in all of us, to substitute the rigid body by a point particle, right? The center of mass particles replace them. So this temptation must be avoided whenever rotation is involved. As long as translation of the center of mass you're talking about, there's no problem. You can always reduce the rigid body or the extended body to a point particle and study what is going to happen. But the moment I begin to talk about rotation of the object, then you can't do that. Then it will not make sense. So these two quantities are independent of each other, right? Like I said, we have been studying the first quantity. We have not even talked about the second quantity. So what you need to remember, what you need to learn, what you need to understand is that since these two quantities are independent of each other, therefore when they are happening simultaneously, then it is just like projectile motion, where motion on the x-axis and motion along the y-axis was independent of each other. But if you want to talk about the velocity of the projectile at any moment in time, then you cannot explain or you cannot talk about the velocity of the projectile at any moment in time just by giving one component of velocity or just by talking about its motion along x-axis. You can, of course, say that, look, for the projectile, there is a motion happening along x-axis and I want to analyze it. And I want to analyze it separately from the motion happening along y-axis. Yes, that's what you do. That is how you exploit the fact that motion along perpendicular axes are independent of each other. So when the object is moving along x-axis, can you apply equations of motion along x-axis? Yes, you can. Can you apply laws of physics along x-axis? Yes, you can. No problem. But if I ask you for the velocity of that object at a certain moment in time, then you cannot get away by just supplying or just telling me the velocity along x-axis. You also have to tell me the velocity along y-axis. In fact, the best or the real velocity, the physical velocity that an observer will observe at that time, of course, would be the vector sum of the x component of velocity and the y component of velocity. Just like that, here also, we will analyze translation separately, we will analyze rotation separately, but then when we talk about the actual motion of the rigid body, it must be the combination of the two. Must be the combination of rotation about center of mass and translation of center of mass. Okay. So the key factor here, the key thing to take away is how do I combine? And it turns out that the combination is exactly the same as the way that you had done in projectile. You simply add two vectors. One vector will be along x-axis. One vector in projectile, one vector was along x-axis. In projectile, the other vector was along y-axis. But here you will have one vector due to translation. It may have any direction, and one vector due to rotation. It may have any direction. And you simply add those two vectors up. That's it. That gives you the combined effect. So first, let us talk about the translation of this object, the rotation of this object, and direction is not causing any hindrance. No. Because यहाँ पे mutually perpendicular directions का independence नहीं है. यहाँ पे ये quantity, यहाँ पे ये quantity और ये quantity का independence. So the independence in projectile was two mutually perpendicular axes. Here, the independence is that of translation and rotation. Okay, so these are three objects which are the same three objects, and this is the center of mass of the object. So we are going to talk about first translation of the object. Okay, so what do we mean by translation of a rigid body? You must be absolutely clear on this. What do we mean by translation of a rigid body? Well, up till now, what we have been saying is that if we are talking about the translation of a rigid body, let's replace the rigid body by a point particle and let's only talk about the motion of that particular point particle. So I want to sort of, मैं इसको एक step और आगे ले जाना चाहता हूँ. I want to elevate that a bit, and I want to now state that, look, whenever I talk about the translation of a rigid body, necessarily it means that every particle on the rigid body has the same velocity as the center of mass. Okay? Please notice the definition of translation. Any particle, I have chosen, I have randomly chosen 5 particles. Any particle on the rigid body must have the same velocity or the acceleration, right? We are talking about motion. Any particle must have the same velocity or the same acceleration as the center of mass. This is the definition of translation. I'll just write it here. All particles on the rigid body must have the same velocity or acceleration as that of center of mass. This is the meaning of translation. Now, what is the meaning of rotation about the center of mass? In fact, you can extend this meaning to rotation about any point. So what is the meaning of rotation about the center of mass in this case? So let me just write it down. Rotation. So rotation means that every particle, okay, please notice what I'm saying. Every particle must have a different velocity. Every particle must have a different velocity. The velocity of any particle on the rigid body is given by, due to rotation I'm talking about, or acceleration, is given by r omega or r alpha if we are talking about acceleration. And it is always tangential, and r is the distance from the origin. So I'll forget about that one. I'll only keep this one. So let this be R, then this is R. And the center of mass itself, right? In any other case, it would be the center of rotation. The center of mass itself is at 0 velocity. I hope this is clear to everyone. Translation, every point has the same velocity. That velocity is equal to the velocity of center of mass. Or another way of saying, another way of looking at this, every point has the same acceleration, which is the same as the acceleration of the center of mass. What is rotation? Well, rotation is when every point has a different velocity or acceleration. The velocity is given by r omega, where r is the distance from the axis of rotation, and the direction of this velocity is tangential. And if we are talking about acceleration, then r alpha is the magnitude of acceleration, where r is the distance from the axis of rotation. And this also is tangential. Please notice that I'm not talking about another acceleration here. I'm not talking about centripetal acceleration, but it is there. Okay? I'm not talking about it. That does not mean that it is not there. Okay? It is there, but we are not going to bother ourselves with centripetal acceleration for the moment. So the net velocity of an object which is undergoing translation plus rotation. Net velocity of an object undergoing translation plus rotation must be the vector sum. हाँ सेंट्रीपिटल क्यों निग्लेक्ट करते अभी अभी बताता हूँ अभी 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 बताता हूँ अभी अभी I'll come back to that. So when an object is executing translation plus rotation, then every point has a velocity. Yeah, I'm talking about velocity at the moment. Every point has a velocity which is the vector sum of the velocity of that point had the object been in pure translation, and the velocity of that point had that point been in pure rotation. So what the theorem is trying to say is that, look, if you want to find out the velocity of a particular point on an object which is rotating and translating, then what you do is you forget about the rotation for a moment and you draw the velocity vector of that point, if considering that the object is only undergoing translation. And then you forget about translation for a moment and you draw the velocity vector of that point only due to rotation. And then you find the vector sum of these two velocity vectors that you've drawn, and you'll end up with the velocity, the net velocity vector of that point. Now, this is going to give us some unusual results, but it is what it is. So this point, let's talk about this point. This point has a velocity v due to translation, and it has a velocity r omega due to rotation, and therefore its velocity will be equal to v plus r omega. Right? Simple vector sum of the green and blue vector will give us the net velocity of that point. The point which is the leading edge of the rotating and translating object will have a velocity v like this due to translation, and it will have a velocity r omega like this due to rotation, and therefore its net velocity must be like this. This is very weird. मतलब आप किसी लेमैन को जाके बोलोगे कि तेरी गाड़ी का जो पहिया जो गोल गोल घूम रहा है, जो गाड़ी आगे जा रही है, तो गाड़ी के पहिए का आगे वाला जो पॉइंट है, जो रिम का पॉइंट है, उसकी वेलोसिटी जो है वो नीचे की तरफ टेढ़ी है. That would sort of elicit a very weird response. क्या क्या बोल रहे हो यार, ये क्या बकवास. But it is what it is. This is what happens. So the velocity of the leading edge of the tire of the bicycle, motorbike, car, whatever it is in this direction, the direction of the red arrow. The velocity of the bottommost point due to translation is this, and due to rotation is this. Please notice that I have taken a clockwise rotation simply out of convenience. It could have been anti-clockwise as well. In that case, you would have to redraw the you would have to redraw the arrows that I'm drawing at the moment. What about this guy? This guy velocity due to translation is like this, and velocity due to rotation is like this, and therefore the नीचे वाला मैंने बनाया नहीं, sorry. So नीचे वाला जो velocity है that can be like this, v minus r omega, and this would be if mod of v is greater than mod of r omega, and it can be like this, r omega minus v, right? This would be when r omega is greater than mod of v, right? Or it can be 0 if v ka mod is equal to r omega. Yeah. Very special point. Very special point. Later on, we are going to see that this is actually the most common case that we'll be dealing with. नीचे वाले पॉइंट का वेलोसिटी 0 है. क्यों 0 है ये भी मैं बता दूंगा. बट रोलिंग की जो कंडीशन होती है वो कुछ मिलती जुलती होगी. नॉट कि 0 होना चाहिए, कुछ और 0 होना चाहिए. I'll tell you what that 0 should be. तब हम बोलेंगे कि वो रोल कर रहा है. If r omega greater than v, r omega greater than v, उल्टा हो गया ना एरो, ये रहा ना r omega greater than v, ये रहा, और ये r omega less than. भाई आप दो वेक्टर का सम निकाल रहे हो जो ऑपोजिट, नीला वाला वेक्टर राइट में है, हरा वाला वेक्टर लेफ्ट में है. नीला 10 है और हरा 2 है. क्या होएगा भाई शानक? नीला 10 है, हरा 2 है. हाँ तो 8 किस डायरेक्शन में होएगा? विच डायरेक्शन? राइट. हाँ, और अगर हरा 8 है और नीला 4 है, अगर हरा 8 है नीला 4 है तो क्या हो जाएगा? 4 ऑपोजिट डायरेक्शन में हो जाएगा. So 0, Pratiksha, does not mean that there is no motion. Okay. After all, when you throw something up at the highest point, the velocity of that object is 0. Does not mean that the object has stopped. Does not mean that the object has stopped. Okay. So the net velocity of this point will be somewhere like this. मैं मैग्नीट्यूड लिख नहीं रहा हूँ. मैग्नीट्यूड लिखना बहुत आसान है. v square plus r square omega square. Now I can give you a physical example of this phenomenon. ये वाला जो एरो मैंने बनाया, इसका मैं फिजिकल एग्जांपल आपको दे सकता हूँ, which may convince a lay person that this is what happens. So बारिश हो रही है, सपोजिंग बारिश में आप सब लोगों ने साइकिल चलाई हुई है. Now a bicycle has a feature on its front wheel and back wheel, which is called a mud guard. Okay. Now, if that mud guard was not there, suppose it, then a particle stuck to the rear wheel. बारिश हो रही है तो particles are sticking to the wheel, and at some point the particles are getting released क्योंकि उसके ऊपर जो force है वो ज़्यादा हो जा रही है. So if a particle is released from this point, right? So remember, this is the rear wheel. इसका मतलब कि जो front wheel है वो यहाँ कहीं है, और यहाँ पे अभी मैं इसको हटा दूंगा, आप यहाँ बैठे हुए हो. तो अगर हमारे पास एक कीचड़ का पार्टिकल यहाँ से इस पे अटैच हुआ और इधर चलते 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 यहाँ पे वो व्हील से छूट गया, right? So its velocity will be the same as the wheel itself, as that point on the wheel itself. and its velocity will be like this. And now it has left the tire. This means that it is only under the influence of gravity now. So it will become a projectile, and the projectile will be like this. So if you don't have that mud guard on your bicycle, and you can do this experiment, you can remove the mud guard of the bicycle. अगर आगे वाले का निकालोगे तो आपके चेहरे पे आएगा, और अगर पीछे वाला निकालोगे तो आपका बैक पेंट हो जाएगा कीचड़ से. So you can actually experience these velocity vectors provided that the particles are leaving at those points. याद है ना, ये पता है ना सबको, मड गार्ड होता है बाइक पे. आई होप एवरीबॉडी हैज मड गार्ड इसलिए होता है. दिस इज व्हाई वी हैव the center of the object will have zero velocity due to rotation, v due to translation, and therefore the net velocity of the center of mass. Finally, I want to look at this point. Okay. So this point has a velocity r omega due to rotation, and it has a velocity v due to translation. So the net velocity of this point will be like this. Extremely weird, non-intuitive, but this is how it works. This is how it works. Please write this down in your copies. I will wait for 5 minutes. Please write this down. Please draw large diagrams so that you will be able to refer back to this later on. मुंह पे क्यों आएगा बट देखो, अगर ये फ्रंट व्हील है और ये रेयर व्हील है और आप यहाँ बैठे हो, पार्टिकल यहाँ से रिलीज हुआ, राइट? तो कैसे वेलोसिटी रहेगी इसकी? ड्यू टू रोटेशन ऐसे, ट्रांसलेशन ऐसे इट इज पॉसिबल कि ऐसे वेलोसिटी हो जाए उसकी, वो क्या है नहीं है। I'm not मतलब सी मैं इतने एग्जैक्ट फिजिक्स की बात नहीं कर रहा हूँ, सीधा जो है आप हा कर रहे हो और आपके मुंह के अंदर चला गया कीचड़, एग्जैक्ट नहीं बात कर रहा हूँ। I'm saying is that you will get it on the front of your body if you sort of अगर आप वो मडगार्ड्स वहां से हटा दोगे फ्रंट व्हील के, रेयर व्हील का जो है वो आपके उसमें आएगा, बैक में आएगा। The point is that the velocity of a particle which is leaving the rim of the wheel has a velocity which is exactly equal to the velocity of that point of the rim of the wheel, which itself is the vector sum of velocity due to translation and velocity due to rotation. Okay. मैं slide change करूं? Can I change the slide? Can I change the slide? I just want to draw the diagram again. But this time I want to draw for acceleration. You also should do this. So can you do it first and then I will do it? आप करो, पहले करो, acceleration के लिए बनाओ। Okay. Now I'm going to draw the the dotted yellow this thing, centripetal acceleration as well. So the net acceleration of this point is A r alpha. Now I'm going to neglect the centripetal and I'm going to write A plus r alpha here. Although there is definitely a centripetal acceleration here as well. And the reason is that when we are going to do numericals, when we are going to solve problems, in 99.99% of the problems, we will use this concept for setting up the constraint equation. And we will find that the acceleration which is perpendicular to this really does not play a role in the constraint relation. So although I have drawn the red, green, blue, and yellow arrows, it turns out that for constraints only the blue, green, and red arrows will be useful, and the yellow arrow will not be useful. Therefore, I have not taken the yellow arrow as part of the net acceleration. But if somebody asks you, may you please tell me the net acceleration of the topmost point, definitely you have to take the yellow arrow as well. Let me just repeat. So A here, R alpha. Oops. Again, I have considered clockwise alpha, which is not a necessity. And the same as velocity, this may be A minus R alpha, or it may be R alpha minus A, or it may be 0. But remember, the yellow wala acceleration is still here. Finally, for this guy, A, please notice that जो side में points हैं, मैं वहाँ पे नेट ये रेड वाला बना नहीं रहा हूँ, क्योंकि जो साइड में पॉइंट्स हैं वो जनरली कंस्ट्रेंट्स में नहीं आएंगे. अगर आएंगे तो वर्टिकल एक्सेलरेशन लेके आएंगे. अगेन फिर येलो वाला रिडंडेंट हो जाएगा. एंड फॉर द arbitrary point A R alpha, अभी देखा ना नहीं, वैसे मैं ऐसे बताने का मतलब है नहीं. अभी मैं जब क्वेश्चन कराऊंगा ना तो देखना. प्लीज नोटिस दैट इन both cases the center of mass always has only the velocity due to translation or acceleration due to translation. Does not have anything else. Please draw this. हो गया. Chalo. So let's see how this works, how this all comes together. I will show you how it comes together by an example. So the question is actually very, very simple. Is that a cylinder of radius r, mass m, has string wound on it and is suspended as shown. It is released by a swing. Okay, very, very simple question. So we take a cylinder and we take some string and we wind on the edgy downward angle. So we take a cylinder, we wind a string on it, okay, ideal string, and we attach one end of the string to the ceiling like this, and we release the cylinder. Okay. When we release the cylinder, now you have to sort of take this leap now, and it's not a very big thing. You have to tell me what kind of motion will be executed as the cylinder moves down, as the rope of the string unwinds. Right? I hope everybody can see that the motion will be that of translation and rotation. So this object will come down definitely, and it will also be rotating. Yeah, rotate and go down. That means rotation plus translation. So please see how I do this. Since the motion is translation plus rotation. So what you do is you forget about the rotation and you look at only the translation of the object. You look at only the translation of the object. So this means that you are drawing the translational FBD. Right? You don't care where the forces are acting. You just know that all forces are acting from the center of mass. So you will say that the tension is acting upwards, mg is acting downwards. Therefore, mg minus t must be equal to m. Notice that I have already assumed that the acceleration of the center of mass is a downwards. इसीलिए मैंने ये इक्वेशन लिखा mg minus t is equal to ma. अगर मैं a upward assume कर लूं, अगर मैं a upward assume कर लूं, right, then I'll have to write down the equation t minus mg is equal to m. But I have a pretty good idea that it will be coming down, so I have assumed the downward acceleration. Yeah. That's what it is. So now I forget about the translation, हो गया translation का काम, and I look at only the rotation. And now I have to draw the rotational free body diagram. That means I am bothered about the point of action of these forces. Okay. And whenever, for the moment, whenever for the moment, बाद में I will show you how to handle other origins. But for the moment, whenever you see a fixed object, like we did in the last class, fixed point will be the origin. Whenever you see a movable object, whenever you see a free object, the center of mass will be the origin. Okay. So here we will choose the center of mass as the origin, and we'll find out the torque. Torque is TR, and that is equal to IR. So I've written TR is equal to I alpha. Because there is only one torque, it is guaranteed that alpha will be in the direction of this torque. I don't need to assume anything here. So I know that the torque due to tensor is anti-clockwise, therefore alpha must be anti-clockwise. Now, please pay attention. We are going to write the constraint equation. So what do we mean by constraint? Again, here there are two types of constraints, the string and the wedge constraint. But both the constraints are far more easy as compared to what we did in LMM. In fact, there is no complication whatsoever. So what the string constraint says is that, look, the 2 points on the string must have, any 2 points on the string must have the same acceleration in the same direction. If they don't, then obviously either the string is going to break or it is going to go slack. So they must have the same acceleration. Now, I have used the statement any 2 points, whereas on the diagram I have drawn 2 specific points. So although the statement is valid for any 2 points, right? Practically speaking, the 2 points must be chosen such that they give you some sort of an insight, some sort of a mathematical relation. So what you do is you choose 1 point of the string which is in contact with the rotating or translating or rotating plus translating rigid body. And the other point you choose, in this case, on the ceiling, or another point you choose, which is connected with, if the string is connected to another body, then you choose that point. So since these 2 points must have the same acceleration, let me just remove this. Let me use the same color. So if these 2 points are to have the same acceleration, then this point has 0 acceleration because it is attached to the ceiling. Now, this point has acceleration A due to translation. Remember, due to translation, every point must have the same acceleration as the center of mass. So here, this point has acceleration A downwards because we have assumed that the center of mass has an acceleration downwards. And due to rotation, it must have an acceleration alpha r upwards, okay, because alpha is anti-clockwise. Right? And the net acceleration of this point, if it is downward, will be A minus alpha r, or if it is upward, it will be r alpha minus A. So the constraint is that the acceleration of this point and this point must be same. So since acceleration of the 2 chosen points must be same, we get 0 is equal to A minus R alpha. Okay. So A is equal to R. Right. Now again notice that there is centripetal acceleration of the lower wala point. There is centripetal acceleration of the lower wala point, but it plays no role because it is perpendicular. So acceleration of 2 points, two chosen points along the string must be same. If I have missed out on that, I must write it. Acceleration of two chosen points along the string, perpendicular to the string, कुछ भी हो सकता है, कोई problem नहीं. Perpendicular to the string, कुछ भी हो सकता है, no problems whatsoever. Along the string, the acceleration must be zero. Acceleration must be the same. ये आया सबको समझ में? This is understood. Now you may say that A is equal to R alpha फिर से आ गया, तो why are we taking so much pains? Well, A is equal to R alpha is not a universal relation. This A is equal to R alpha is not coming from the rotation of a rigid body, जहाँ पे हमने वो एक relation निकाला था, tangential acceleration is equal to R alpha. This is a completely different object altogether. And this constraint is not a universal relation. It may be different in different circumstances. In fact, in the next question, it is going to be different. So be very, very careful about this. Although this will be very prevalent, it will be very common. That does not mean कि आप इसको रट लो कि हमेशा यही होता है. So let me write the equations. mg minus t is equal to ma. PR is equal to mr square by 2 into alpha, which is a by r. ये cancel हो गया, ये cancel हो गया. So this gives us mg is equal to 3ma by 2, right? And this tells us that a will be equal to 2g. Okay. One thing that I have forgotten, which I keep on forgetting, which is actually very pardonable, but still, the string does not slip. This statement must appear in the question. If it does not, then you can take the statement as is. हाँ भैया है, slipping नहीं हो रही है. Because if there is slipping, then this constraint relation will not hold up. And if this constraint relation does not hold up, then you end up with two equations and three unknowns which cannot be solved. So if there is slipping, then there are problems. So no slipping की condition string में हम हमेशा assume करके चलेंगे, unless of course specifically given है. इस case में, like I said, we'll be discussing it at the end of the chapter, how to deal with slipping. If there is no slipping, then you can call it, in this case, actually वो हमेशा फ्लोर के लिए यूज होता है, but ठीक है, यहाँ पे भी आप बोल सकते हो ये रोल कर. This is rolling. I hope this is understood by everyone. Any doubts in this? Any doubts? Your turn now. हाँ, स्लिपिंग का मतलब, हाँ ये पूछना चाहिए. स्लिपिंग का मतलब हुआ कि ये जो डिस्क है, if it turns an angle theta, then the length of the string liberated is r theta. If the pulley, if the disc rotates by an angle theta, then the length of the unwound string is r theta. This is what it means. Okay? This is the meaning of no slipping. Okay, so let's try now a question. Find acceleration of lower cylinder. Both cylinders are identical. No slipping. So this cylinder is fixed but free to rotate, and the lower cylinder is free. String is wound on both the cylinders, and the system is released. बताओ भाई, कोई तो बताओ क्या हो गया। गलत गलत आंसर, गलत। उत्कर्ष तेरा भी गलत। बहुत बढ़िया प्रतीक्षा, यस। तरुण का आंसर बिल्कुल सही है, यस। पार्थ गलत आंसर। This guy. So this guy has what kind of motion? It has pure rotation. Okay. बहुत बढ़िया चित्र, very good. Pure rotation में mention T mg from T dash. So we get PR is equal to I alpha. Notice that this alpha is anti-clockwise. This guy is having translation and rotation. For translation, T upwards, mg downwards. So we will write mg minus T is equal to ma. This means that I have assumed that acceleration A is downwards. And for rotation, we will have T mg. Again, we will get TR is equal to I alpha. Two things I want to point out here. First, because this torque and this torque and this I and this I are same, therefore this alpha and this alpha are same. Otherwise, they would not have been. Identical cylinders under identical torque will give identical alpha. This is the first thing. Second thing is, although the magnitude of both alphas are same, the direction of both alphas are not same. ऊपर वाला अल्फा एंटी क्लॉकवाइज है, नीचे वाला अल्फा क्लॉकवाइज है, as is evidenced by the direction of, if you look at the T, it is producing an anti-clockwise torque on the upper cylinder, and the T is producing a clockwise torque on the lower cylinder. Okay, now the acceleration of this point must be R alpha. The acceleration of this point must be A due to translation, R alpha due to rotation. Therefore, in this direction, the acceleration must be A minus R alpha. So the constraint relation that you will get will be R alpha is equal to A minus R alpha. Therefore, A is equal to 2R alpha. नहीं, calculation mistake किया है. Now I'll just write the equation and solve. Mg minus T is equal to Ma. Tr is equal to I alpha. I is mr square by 2. alpha is a by 2r, so r square cancels out. If I add these two guys, I'll get mg minus t is equal to 4 by 5 ma. Sorry, t nahi aayega. Therefore, a will be equal to 4g by 5.
सर 5/4 में होगा ना?
किस कहाँ गलती कर रहा है सर, कहाँ गलती कर रहा है?
तो एक तो कॉन्स्टेंट में गलत हो गया।
और
सर कंस्ट्रेंट में गया।
सर आप वहाँ उल्टा लिखते हो, 5/4 में होगा ना?
this is clear to everyone? ऊपर वाले का रेडियस मैटर नहीं करता है बिकॉज इट इज एन आइडियल पुल. नहीं, रोटेशन उसका मैटर नहीं करेगा प्रतीक्षा, मासलेस है वो. ऊपर वाली पुली इज मासलेस, देयरफॉर इट हैज नो role to play in the question. नहीं अंशुल गलत है, नहीं शोना गलत आंसर। नहीं नहीं जी नहीं होएगा, जी पॉसिबल नहीं। मास पे डिपेंडेंट होएगा प्रतीक्षा, मासेस डिफरेंट है दोनों। हाँ उत्तर सही लग रहा है। So we follow what we have learned. We don't follow our instincts कि नहीं है तो ऐसा होगा वैसा होगा. We will say that this is moving I don't know, up. Could have taken it down. This is moving down. I could have made this up as well. Does not matter. नहीं उत्तर तेरा आंसर गलत है. I could have asked a question like, what is the ratio of M is to M so that the cylinder remains at rest? This I could have asked. So please follow me very carefully. Please follow me. See, for translation, for translation of, sorry, शायद तेरा सही है. For translation of M, we have T, we have mg minus mg is equal to for translation of M, we have mg T, mg minus T is equal to M. For the rotation of M, T, G, TR is equal to I alpha. Now, since this TR is clockwise, therefore alpha must also be clockwise. Okay, now please follow me very, very carefully. Due to translation, the acceleration of this point is A1. Due to rotation, the acceleration of this point is R alpha. Therefore, the net acceleration of this point must be, if it is downward, can be up also, A1 minus R alpha. अगर मैं ये रेड एरो ऊपर ले लेता तो I would have to write R alpha minus alpha. But मैं नीचे एक reason से ले रहा हूँ. The reason is again the string constraint. तो मैंने आपको बताया कि any 2 points on the string must have the same acceleration along the string. This is the point on the string. This is a point on the string. So this guy has an acceleration upwards. This guy has an acceleration A1 minus R alpha downwards. तो ये दोनों इक्वल होने चाहिए। a is equal to a1 minus r alpha। नाउ यू मे आस्क कि अगर यहाँ पे हम ऊपर ले लेते तब क्या होता? अगर ऊपर ले लेते तो r अल्फा माइनस a1 हो जाता, और उस केस में हमें लिखना पड़ता a is equal to माइनस r अल्फा माइनस a1, बिकॉज ये ऊपर की तरफ है, ये भी ऊपर की तरफ है, but the acceleration along the string must be same. That means it must be same in magnitude as well as in direction. I hope that is clear. And in this case also, please notice that centripetal acceleration is there. Yeah, है centripetal acceleration, but it has no role to play in constraints. So now let us write the equations. I think I'll go on to the next slide to write the equations. So we have P minus mg is equal to ma. We have mg minus t is equal to ma1. We have PR is equal to I alpha, which I can write as mr square by 2. And we have A is equal to A1 minus R. So what I will do here is that first I will expand this. I will write mr square by 2 into alpha. R यहाँ से कैंसिल हो गया। ये इक्वेशन मेरे लिए बन जाएगा 2t by m is equal to r alpha. Okay? ठीक है ना? अब मैं क्या कर रहा हूँ, मैं ऊपर वाले इक्वेशन को लिख रहा हूँ g माइनस t by m is equal to a1, और मैं इन दोनों को सब्ट्रैक्ट कर दे रहा हूँ। If I subtract, I'll get नीचे वाले से ऊपर वाले को सब्ट्रैक्ट करना है। g minus 3t by m is equal to a minus r alpha, a1 minus r alpha is equal to, because I need to use this as well. Okay? And now in this equation, I'm multiplying 3 by capital M. 3t by capital M minus 3mg by capital M is equal to 3ma by capital M. And I'm writing this equation here. G minus 3t by M is equal to A. Now I'm adding these two guys. So I'll get G minus 1 minus 3m by M is equal to 1 plus 3m by M. Okay. So I get A is equal to m minus 3m upon m plus 3m. G. I think किसी का करेक्ट नहीं है। मैं वो 3 का फैक्टर देख के बोल रहा था कि सही, शायद सही। Is this understood? Anyone has a doubt? You must ask. आपको अभी पूछना पड़ेगा, डाउट कहाँ है? Any doubt? Oh, आ गया। मैं फिर से रिपीट कर रहा हूँ। सबसे पहली चीज मैंने देखी कि आइडियल पुली लिखा हुआ है। आइडियल पुली मतलब उस पुली का अब हमारे पास कोई रोल नहीं, ठीक है, एक्सेप्ट ऑफ कोर्स वो अगर पुली के ऊपर एक और पुली लटकी है, याद है ना वो 2t is equal to t, t1 is equal to 2t2 जो भी करते थे, अगर आइडियल पुली दी हुई है। इस केस में आइडियल पुली फिक्स्ड है, इसका कोई रोल मेरे सामने नहीं है। दूसरी चीज मैंने देखी कि जो मास स्मॉल m है, जो ब्लॉक है, वो केवल ट्रांसलेशन एग्जीक्यूट करेगा। तो चुपचाप मैंने उसके लिए एफबीडी बनाया और मैंने उसके लिए इक्वेशन लिख दी और अपने मन से मैंने अपवर्ड एक्सेलरेशन अज्यूम कर लिया। मैं दोनों का अपवर्ड एक्सेलरेशन अज्यूम कर सकता हूँ, दोनों का डाउनवर्ड अज्यूम कर सकता हूँ, एक का अपवर्ड एक का, जैसा मन हो आप वैसा कर सकते हैं। उसके बाद से मैंने देखा कि जो राइट हैंड साइड वाला सिलेंडर है वो रोटेशन प्लस ट्रांसलेशन एग्जीक्यूट कर रहा है। तो उसके लिए रोटेशन के लिए मैंने नहीं तुलिका कुछ मेमोराइज नहीं किया, मतलब एक्सेप्ट जो मैं बोल रहा हूँ। तो रोटेशन के लिए मैंने ट्रांसलेशन के लिए मैंने ट्रांसलेशन एफबीडी बनाया, एफ इज इक्वल टू एम ए लिख दिया। रोटेशन के लिए मैंने रोटेशनल एफबीडी बनाया और टॉर्क इज इक्वल टू आई अल्फा लिख दिया। प्लीज नोटिस that I assumed the direction of A, I assumed the direction of A1, but I did not assume the direction of alpha. And there is a very big reason for this. I hope you have understood. For the block M, there is an upward force and there is a downward force, and I really don't know which one is bigger. Therefore, I cannot say for sure whether the acceleration of small m will be up or down. If you look at the cylinder on the right hand side, that also has the same problem. There are two forces in the vertical direction and I don't know which one is bigger, so I don't know where it will accelerate, where the center of mass will accelerate. Therefore, I am at liberty to choose. However, when it comes to torque, there is only one torque. Therefore, I cannot choose. It is given to me, literally it is given to me that alpha will be clockwise. There is no doubt here. In future, of course, you are going to get questions where the system will be subjected to more than one torque. In that case, you will treat it simply as I have treated the block. That means, since you will not know कि clockwise torque बड़ा है या anti-clockwise torque बड़ा है, you will assume कि ठीक है भाई, अगर clockwise torque बड़ा है तो let's take the alpha as clockwise. Once I have done that, then I have looked at looked at 2 points on the string, one attached to the block and the other attached to the cylinder at that particular point on the rim. And I have found the acceleration of these 2 points along the string, and I have equated these two accelerations. Once I have done that, then I can write these equations and so on. Now, like I said, I can ask you a question. What is the ratio of m is to m such that the block of mass m remains stationary? What is the ratio of m is to m such that the block of mass m remains stationary? Can you answer now? Is it obvious? Yes, it is 1:3. And you can also answer now, क्या रिलेशन मासेस में होना चाहिए कि वो ब्लॉक ऊपर जाने लगेगा, क्या रिलेशन मासेस में होना चाहिए कि वो ब्लॉक नीचे जाने लगेगा. तो हमने तो नीचे जाते हुए अज्यूम किया है, राइट? नीचे ऊपर अज्यूम किया ना. हाँ, हमने ऊपर अज्यूम किया. लेकिन अगर ये जो लेफ्ट वाला ब्लॉक है ये सिलेंडर के मास से 3 टाइम्स 1:3 के रेशियो से ज्यादा हो जाएगा, then it will start to come. Okay, so I hope this was clear to everyone. We will continue doing questions in the next class because I have lots and lots of questions to discuss, lots and lots of cases to discuss. अभी हम केवल strings कर रहे हैं. Next class में एक दो question string के करके फिर surface करेंगे. Again, the constraints are very easy for the surface as well, not difficult at all. Right? And then we'll move on to work energy. चलो, okay. So any other doubt? Any doubt, guys, before I go? Any doubts before I go? सबको सारा समझ में आ गया? वाह, वाह शौनक, अगली क्लास में जो मैं प्रॉब्लम दूंगा वो हो जाना चाहिए. चलो, ओके. हाँ, good. चलो, बाय बाय. इसके बाद क्लास नहीं है क्या? क्लास होएगी ना इसके बाद?
Yes, sir.
उनको आवाज नहीं आ रही. क्लास है ना इसके बाद? मैथ्स है क्या? ओके.